But if you do complete it, you do get rewarded by getting extra points, and you have to show all your work and do all of the review. So, and then you're going to take your part 1 of your test, which is going to be multiple choice. There's 10 multiple choice questions. Yeah, tomorrow is Thursday. 10 multiple choice questions on Friday, and then on Monday you will complete your I call it Unit 1 writing assignment. It's not really writing, but it's just like the written part of your test. So you will do that on Monday, and you get unlimited attempts on that. All right, so let's go ahead and talk about our word of the day. Today's word of the day is inequality. Does anybody know the difference between an inequality and an equation? You can go ahead and type it in the chat what you think the difference might be. Anybody have any ideas? That's okay, Micah. So if you've been working in the course, then you're probably pretty familiar with inequalities and equations. So an equation is going to have an equal sign, and there's only going to be one solution. Good, Ty. When we have an inequality, we can have a few different signs. We can have less than or equal to, greater than, or greater than or equal to. And our solution is going to be a set of numbers. So that's what we're going to go over today. So what's the difference? Well, when you're solving for an equation, that means you are going to have one answer or one solution. For example, if my problem is x plus 2 equals 4, that's an equation. There's an equal sign. I subtract 2 from both sides, and I get x equals 2. So 2 is the only number that can make that equation true. When I have an inequality, that means we're going to have a set of numbers. So for example, x plus 2 is less than 4. That's right down here. Oh, that's hard to see. So again, I'm going to solve them mostly in the same way. Subtract 2 from both sides, and I get x is less than 2. So this means that any number that is less than 2 would make my inequality true. So I could have 2, I could have 0, I could have negative 2, I could have negative 200. Any number less than 2 makes the inequality true. So today we're going to review our vocabulary terms. We just did that. We're going to work on solving inequalities. And then if you have not taken your 1.07 quiz or done your 1.07 homework, I'm going to give you a few minutes at the end to go and do that. So today we're going to, you're going to be able to solve multi-step inequalities and graph their solution on a number line. All right, so graphing inequalities. The first thing I want to focus on is these are our inequality signs, and we have to know how to read them or what they mean. So this first one, we read it as whatever number would be on the left, less than. So for instance, 1 is less than 3. Okay, less than. This next one is less than or equal to. The third one is greater than. And if it were me, I would have a piece of paper right now and write these down, because when we go to solve, once we've solved our inequality, when we go to graph the solution, we actually need to know how to read these so we can graph our solution correctly. So let's talk about these indicators. So these are open circles versus closed circles. So if you're wondering what they mean, it's either an open circle or a closed circle. So you will notice that the open circles happen when we have an inequality that is strictly less than or greater than. If we have the equal to sign underneath, then it's a closed circle. So now that I know what I need to use for graphing inequalities, why? Okay, that's a good question. So it's closed because it's equal to. So let me show you on this next slide. For number 1, we have n is less than or equal to 0. So what I'm going to do is draw a circle around 0. Actually, let me use a different color. I'm going to use blue. Circle around 0. And because this has the equal to sign underneath, I'm going to color it in. So what that tells me is that I can include the number 0 in my solution set. Because if I plug in 0 for n, I get 0 is less than or equal to 0. Is that a true statement? Yes. So 0 is not less than 0, but it is equal to 0. So that's a good question, Micah. The reason we're going to have a closed circle when there is an equal to sign is because we want to include that number in our solution. So now I have to shade my numbers that are in my solution set. So the reason that it's important that you're able to read your inequality signs is we have n is less than or equal to. So I want all of the numbers for n that are less than or equal to 0. So I'm going to shade all the numbers to the left. Any questions so far? Okay, so let's look at number 2. We have P is less than -2. So I'm going to go to -2 and I'm going to draw my circle. I'm going to leave this one open because if I were to plug in -2 for P and ask myself, is -2 less than -2? No. It's equal to, but it's not less than. So I'm going to leave that open. Now, I want to shade all of the numbers for P that are less than -2. So I'm going to go to the left again. Yes. So an open circle means it is not equal. A closed circle means it can be equal. Yep, that's exactly right, Micah. Okay, any questions? Okay, so let's try number 3. We want T greater than or equal to 1. So I'm going to put what kind of circle at 1? Open or closed? What do you think? Should I fill it in or leave it open? So remember, if it's equal to, I'm going to fill my circle in. So I'm going to have a closed circle. And I want all of the values that are greater than 1. So I'm going to shade to the right. Okay, now this next one, number 4, can be a little bit tricky because our x value, our variable, is on the right-hand side. So it's a little bit different to read. But let's go ahead and read this. It says -3 is greater than x. So -3, put a circle around it, is bigger than all of my x values. So I want all x values that are smaller than -3. So I'm going to shade to the left. Okay, so if you are working on your homework in 1.07 or your Unit 1 writing assignment and it tells you to graph your solution, this is what you are going to do. You are going to graph your solution for your inequality on a number line. Okay, so we said we were going to work today on solving inequalities. So solving inequalities is just like an equation. There's just one difference in the solving part of it. If you multiply or divide both sides by a negative number, you're going to flip or switch the way that the inequality symbol faces. Yes, Nola, it was -3 is greater than x. Or if you wrote it the other way, it would be x is less than -3. Exactly. Okay. So let me show you a problem here where this flipping the switch or the flipping or switching the inequality symbol would come into play. So solving inequalities, we're going to do the same thing that we normally do for solving equations. I'm going to find my variable, which is x, and I ask myself, okay, what is happening to x? This says -4 times x is less than or equal to 16. So what's happening to x? It is being multiplied by -4. So to undo multiplying by -4, I'm going to divide everything by -4. I'm going to be left on the left-hand side with x. Now, my sign is going to switch because I divided by a -4. And then I have 16 divided by -4, which is going to be -4. So now my solution is all x values that are greater than or equal to -4. Other than the flipping of the sign, solving inequalities is the same exact steps and method as solving equations, which is what we were working on last week. So let's try another one. I'm going to do the one on the left, and then I'm going to ask for a volunteer to do the one on the right. So the first thing I'm going to do is find my variable. It's y. And I ask myself, what is happening to y? This inequality says y plus 14 is greater than or equal to 32. So what's happening to y? It's getting 14 added to it. So to undo adding 14, I'm going to subtract 14 from both sides. 14 minus 14 becomes 0, so I get y is greater than or equal to 18. Now that I have my inequality, I'm going to graph my solution set on a number line. So what I like to do is whatever my number is in my solution set or my inequality, I put that right in the middle. And then I just usually do like one number to each side. So to graph my solution, I'm going to put a circle at 18. And I'm going to fill this one in because it was greater than or equal to. So it's going to get filled in. And I want all y values greater than 18. So that means I'm going to go to the right. Okay, do I have anybody, if you would like to raise your hand, that would like to try to write out the steps to solve this one? Awesome. Thank you, AJ. And then if you'll graph it on the number line at the bottom.
Okay.
Thank you. And then if you are not AJ, you are going to be solving this on your own paper. Great start, AJ. You're doing good. Okay, so the first thing AJ is going to do, so she's not subtracting 11, Micah. She's adding 11. So right here, our variable is z. So what's happening to z? It's being multiplied by -4, and 11 is being subtracted from it. So we always want to undo addition and subtraction first. So AJ added 11 because we were subtracting 11, so she added 11. 5 plus 11 is 16. So then she divided by a -4. And remember, when we divide by a -4 exactly, AJ, she's going to switch her sign. Yeah, that's okay. No problem. So then she gets -4 is less than or equal to z. So z is greater than every number, greater than -4. So every number for z has to be greater than or equal to -4. Great job, AJ. All right, so she's going to put a closed circle at -4, and then we want all values greater than -4. So actually, we're going to shade the other way, AJ. Micah, that's a good question. So I didn't switch on the last problem because when is the only time I'm going to switch my sign? When do I switch? When I do... Okay, so look at the bottom here, the statement. It says, did you multiply or divide by a negative? So the only time you're going to switch your sign is if you multiply, good Nola, or divide by a negative number. So just subtracting, that doesn't count. Everything stays the same with subtraction. But when you multiply or divide by a negative, that's when your sign is going to flip. Good question. Good question. Okay. So now, do I have anybody else that would like to volunteer to try one of these two? It's okay if not. AJ, do you want to do another one? No? Okay. Oh, good. Amari, thank you. I'm going to put you right here. Okay, awesome. Amari, I'm going to put you there. And then AJ, I'm going to put you over here. So there's a couple things that could be potentially tricky on these. On the left, we have minus G. Okay, so after you move your 3, you're going to have to multiply or divide everything by a -1. On the right-hand side, AJ's problem, we're going to have to start off by multiplying by the reciprocal of our fraction. Okay, so I'm going to give us about 2 minutes to work on these, and then don't forget to go ahead and graph your solutions at the bottom. What do you mean? Do you always use the number on the right? Maybe. I'm not quite sure what you mean by that. Like, do you use it to... Well, I don't know. What do you mean by... Sorry, what do you mean by use it? Well, it's always going to stay there, right? So we're going to always use it in some way. So like on AJ's, we're not going to mess with the number on the right first because that's not where our variable is. So for the problem on the right, we find X and we ask ourselves, okay, what's happening? So this is 3/4, right? 3 divided by 4. So we want to undo that. So we're going to multiply by the reciprocal. So we're going to flip that fraction and multiply it on both sides. The reason we do that is because 4 times 3, so I'm up here at the top. I don't know if I can write. No, I can't. Okay. Yeah, you're always going to, you want to get the variable by itself. So you're only moving things away from the variable. Okay, close, Amari. I'm going to, hold on just a second. So on yours, when we subtract 3, okay, so if everyone will pause for just a second and take a look at Amari's problem, the first one. Yeah, so it's not +3, but he did the first part was perfect. Great job. So subtract 3. Awesome. But we're still left with this negative G. So we have negative G is less than 6. So what we need to do now to get rid of that negative is we're just going to divide everything by a -1. Because -1G divided by -1 is going to now be positive. Make this a little bigger. And then since we divided by a negative, we're going to flip our sign. So now we want all the numbers for G that are greater than -6. So will you regraph that one for me? All right. Yeah, so I would try to put like -6. Oh, you have it on there. Perfect. There you go. And good. It's going to be an open circle, and then we're going to shade it to the right. Perfect. Yay. Smiley face. The -1 comes from, I have to get rid of the negative that's going with the G. So negative G is the same thing as -1G. I need to get rid of that negative. So I divide by a -1 because a negative divided by a negative becomes a positive. It's not invisible. It's an invisible 1, yes. Yes, it is an invisible 1, definitely. All right, so now let's go ahead and look at AJ's problem. So AJ had 3 divided by 4x, okay, times x. So we're going to undo that by multiplying by the reciprocal. So when you multiply fractions, you're going to multiply straight across the top. So 4 times 3 would be 12. 3 times 4 would be 12. And 12 divided by 12 is 1. So Micah, this is like where that invisible 1 would come in again. That's the reason we multiply by the reciprocal, is so that we can get rid of it. We can get it down to 1. And then AJ put her work down here. That's perfect. Thank you. For 3 times 4/3. So again, we multiply straight across the top. 3 times 4 is 12. 1 times 3 is 3. 12 divided by 3 is 4. So then she just put that right back up here. So we want all x values that are greater than or equal to 4. So she put a closed circle at 4, shaded to the right. Very good. Okay, we're going to do 2 more. These are a little bit tricky. I'm going to do the one on the left first, because I want to go over some distribution stuff. So before we can do anything with solving, we have to get rid of this 4 that's right next to the parentheses. So we're going to go ahead and multiply this out. So 4 times 5n is 20n. 4 times 5 is 20. We keep our n. Now we also have to do 4 times -7. So that's going to give us -28. And I'm going to now rewrite the rest of my problem. Did I lose anybody, or is anyone confused on how I got any of that? Okay, good deal. Yay. All right, so now we're going to combine our like terms. So we have 20n on the left side. We have 10n on the right side. So we've got to move. I always like to move the smaller one. We're going to subtract 10n from both sides because we want to get them on the same side. So on the right-hand side, I had 10n. That was a positive 10n. So I want to move that. So to move a positive 10n, I'm going to subtract 10n. So now on the left, I have 20n minus 10n. And notice when I subtracted my 10n, I subtracted it from the other one that had an n. We don't want to do -28 minus 10n, okay, because 28 doesn't have any n's. So I can't take 10 n's from something that doesn't have any. All right, so I've got 10n minus 28 is greater than or equal to 2. Now I'm going to add 28 to both sides. So I get 10n is greater than or equal to 30. I'm going to draw it up here. So I'm going to divide by 10. N is greater than or equal to 3. I'm going to put 3 in the middle, 2 and 4. All right, so I'm going to put a closed circle at 3 because I have greater than or equal to. And again, I want n values that are greater than or equal to 3. So I'm going to shade to the right. So Micah, the reason that I subtracted 10n was because it's the smaller number. I could have subtracted 20n. That would not have been a problem. And then on the right-hand side, though, I would have got -10n. So then I would have been eventually dividing by a negative, which means I would have had to flip my sign. So it's just a few more steps if you do it that way, but you totally can do it that way and still get the same answer. It's a good question. I also like to keep my variable on the left-hand side because it's a little bit easier to read my inequality that way. All right, so y'all tell me on this problem on the right, what is my first step going to be? What should I do first? I can give you a little hint. Yeah, I'm going to multiply or distribute the -3. Yeah, good. So I'm going to get -3x minus 3 is less than or equal to -18. And what will be my next step? Anybody? Close, Micah. So 3 is already being subtracted. So if I look at x, here it is. This says -3 times x minus 3. So since 3 is already being subtracted, I want to do the opposite of that. So I'm going to add 3 to both sides. That's okay. -3x is less than or equal to, I'm going to get -15. All right. What's my next step going to be? Good, AJ. Divide by what? Good. Yes, exactly, AJ. And I'm going to have to flip that sign. Very good. So I'm going to divide everything by -3. So I get x is now greater than or equal to 5. Very good. All right. And then I'm going to go ahead and graph this. Oh, I did not finish my problem. That was weird. All right. I'm going to go ahead and graph this. So I'm going to have a closed circle at 5, and I'm going to shade to the right. Okay, I want to do a challenge question together. This is like our deepen our extension problem. So this is a multiple choice question, and the answers they give you are the solution sets. But in order for us to know the correct answer, this is kind of a two-part problem because we have to solve it and then find the correct solution set, right? So let's go ahead and solve this problem. The first thing I'm going to do is add 10 to both sides. So I'd get 2x is greater than or equal to 14. And I'm going to stop here and let y'all go ahead and finish it and then choose the correct graph, A, B, C, or D. Good. Most of y'all are getting it right. Very good. Yeah, good, Micah. So we know that it cannot be A or B, because if we just look at our inequality sign, it says greater than or equal to. So since we have that equal to under there, that means we're going to have a closed in circle. So when I finish solving this all the way for x, if I divide both sides by 2, I get x is greater than or equal to 7. So I want a closed circle at 7, which would be like right here. And I want all numbers greater than 7. So I'm going to shade to the right. So C would be my correct answer. Okay, so before I send you off to do whatever it is you need to do, if you would just type me, you can send me a private message. I'm going to give everybody whiteboard tools if you want to type it on or write it on the whiteboard. But tell me a difference between solving equations and solving inequalities. There's a couple things that are different, but just give me one. You can put it in the chat. You can send it to me privately. You can write it. You can type it. Okay. Good, Marilee. So the signs that distinguish left and right. So Micah, actually, there are a bunch of practice problems. There's 10 practice problems in the 1.07 homework. So before you go take your quiz, you should, there's 10 problems you can practice on. And when you type in your answer, it'll check it for you. Nola, very good. Inequalities have more than one answer. Equations only have one. Very good. Yeah, good, Megan. The amount of answers. Good. Flipping the signs when we multiply and divide. Good. The sign, the amount of answers. Very good. Okay, so now what I want you all to do is I would like for you to do one of two things. Some of you may have all of this done already, but if you have not done your 1.07 homework, so that's your homework in class kick. So if you haven't done it, or if you did it but you got a bad grade on it, I want you, it should tell you if it's red or green. So that's kind of weird because it at least shows me. Okay, let me look. Let me go to the homework real quick, and I'm going to make sure I have. Okay, so now I think it should tell you. I'm sorry about that. It was not, the button was not checked for it to actually grade your homework. So thank you for letting me know. Now it should be on there. So if you have not done your 1.07 homework, or you just want to practice a little bit more before you take your quiz on 1.7, you're going to go to log into your class kick right now and do 1.07 homework. If you've already done 1.07 and you feel really confident after the review today, I want you to go into the course and take your 1.07 quiz. That's okay, Nola. Yeah, you just do what you can do. I know you've been out sick. I'm so happy to see you in here today. Okay, so you're doing one of two things. You're either going to do your homework if you've not done it, or if you want to practice before you take your quiz, or you're going to take your quiz. If you've already done both of those things, you are free to go. Have a great day, and good luck on your test on Friday.